Hello and welcome to the Team Nova channel. In this video we'll show you how to make your very own homemade volcano. We're going to take you through the civil engineering, chemical engineering and mechanical engineering aspects of the design that need to combine to make it all work. We'll start with the civil engineering aspect of the experiment, the construction of the structure. To make the volcano we need to make two main components. The first is a big plastic bottle with a newspaper ring. The second is the paper mache surface. Firstly, we need to cut out a section in the middle of the bottle. We then use tape to reattach the top to the bottom, reducing the height of the volcano and therefore the volume. This will ease the paper mache construction and be beneficial to the eruption. We then need to roll up a sheet of newspaper into the cylinder, bend this cylinder around the bottom of the bottle and attach to the bottle with tape. If you repeat this a couple more times, the bottle should look like this. So now the bottle is ready for use. Onto the paper mache. For the paper mache component, we need to first dilute the PVA glue by mixing it in a suitable container with approximately 2 parts water for each part glue. In this case, we used around 100 grams of glue and 200 milliliters of water. Next, we need to cut some sheets of newspaper into long strips. Now everything's ready for us to do paper mache. Dig your strips of newspaper into the glue mixture and apply them to the bottle until you get a volcano shape. After this, you need to leave it to dry for around a day. So, why is it now rigid and structurally sound? The first component, the bottle, exists to provide a frame to support the mache as it dries, and a vessel to keep the fluid off the paper. The second component, the paper mache, becomes hard as the water evaporates out of the glue mixture, causing the newspaper to adhere to the bottle itself. Lastly, the volcano is painted to make it look the part. We'll now go through the chemical engineering process, which involves the fuel needed for a reaction. All that's needed is around 4 tablespoons of bicarbonate soda and a small bottle of vinegar. But why exactly would the volcano erupt when the vinegar is added to the bicarbonate soda? This is an example of a classic chemical reaction between an acid and a carbonate. The acid is the acetic acid present in the vinegar. The carbonate present within the bicarbonate soda is called sodium bicarbonate. When they come into contact, they react to form a salt and water. But most significantly, the reaction generates carbon dioxide. Now we're on to the mechanical engineering aspect. In this case, it's focused on safety. We want to avoid proximity with the reaction, but how can we pour in our ignition from a safe distance? We can do it really simply with some string, some tape, and a couple of humans. We have to cancel out the downward force of gravity to suspend the bottle in the air. We can of course just pull the bottle straight up, but that won't keep you at a safe distance. We need 2 people to pull the bottle in tension using a tied piece of string for leverage. Although it just looks like each person is pulling to the side, they're actually pulling upwards and to the side. The horizontal forces are cancelled out as opposing forces, and the vertical forces cancel out with gravity. So hey, you have a suspending bottle. But how can we now manipulate this bottle to pour? With one piece of string, we have control over one range of motion, up and down, but we also need rotational motion. For that, another pivot point is needed by tying an additional bit of string further down the bottle. The first bit of string is holding the bottle up for us, so the second bit of string can focus on tilting the bottle. Together, we can puppeteer the bottle and control its movement quite well. Now we can suspend and pour from a safe distance. Okay, so we've taken you through the civil engineering, chemical engineering, and mechanical engineering knowledge needed for this experiment to succeed. Now it's very much the case that we need to do the same in our engineering roles for Magnox, who are a nuclear decommissioning company. For example, We want to harden and store nuclear waste, and one of the ways we do this is through cement encapsulation. For that, you need civil engineers to consider the structure of the box the waste will be contained in so that it is very strong and it can last a long time. Chemical engineers must consider how the cement will react with the waste to make sure it hardens correctly and to know exactly what will be released in the chemical reaction. Mechanical engineers will want to make sure this process can happen as safely as possible, using automated machinery so that the operators are at either a safe distance or don't have to spend a long time near the waste. We hope you've enjoyed watching. Stay tuned for more content from the Team Nova channel very soon. See you next time.